For centuries, the origin of the oldest human remains on Earth has been one of archaeology's most tantalizing mysteries. Who were these ancient people? Where did they come from? And how do they fit into the sprawling story of humanity's evolution? The skeletal fragments, discovered in remote corners of the world, were thousands of years older than the pyramids of Egypt or the cave paintings of Europe. Some remains date back over 300,000 years, so ancient they challenge our very definitions of human. The bones sat in museums and labs, studied, debated, and sometimes dismissed. But one thing remained constant: their true identity was elusive. Were they our direct ancestors or an extinct cousin species? Did they originate in a single place or from multiple migrations that have long since been forgotten? Now, for the first time in history, thanks to revolutionary breakthroughs in ancient DNA technology, scientists have traced their origins, not just in space, but in deep time. The mystery is no longer unsolved. The answers are here, and they're more astonishing than we ever imagined. I'm on a road to get 1,000 subscribers as a small channel. If you want to help me, please subscribe. In a dry, windswept basin near the border of Ethiopia and Kenya, a team of paleoanthropologists brushed away the ancient dust of time and revealed something extraordinary: fragments of a human skull embedded in layers of sediment over 200,000 years old. The find, now known as Omo-1, would later be joined by other ancient remains discovered in places like Morocco's Jebel Irhoud and South Africa's Florisbad. These were not fossils of distant evolutionary cousins like Neanderthals or Denisovans. These were us, anatomically modern Homo sapiens. The implications were enormous. These discoveries suggested that our species emerged in Africa far earlier than once thought, pushing the timeline of modern humans back by tens of thousands of years. But the discoveries raised more questions than they answered. Who were these early people? How far did they spread? And why did some lineages vanish while others survived? The remains themselves, though incredibly ancient, offered little beyond their physical structure. Skull shape, jaw angle, and cranial volume could only tell researchers so much. Without genetic evidence, the deeper story of ancestry and migration was locked away. For years, the remains were housed in national museums and academic institutions, occasionally reanalyzed as new techniques emerged, but never fully understood. Scholars debated whether these early humans were truly part of the Homo sapiens family tree or represented a now extinct parallel branch. Their features often blended primitive and modern traits, creating a puzzle of mixed evolutionary signals. Some suggested multiple origins for modern humans across Africa, a mosaic rather than a single point of origin. Others believe these fossils belonged to small, isolated populations that failed to contribute to modern human ancestry. Despite the heated debates, no one could offer definitive answers. The bones were too old for traditional DNA extraction, the climate was too harsh, the organic material too degraded, the mystery of their identity persisted. And yet, beneath the enamel of a molar or sealed in the dense matrix of the petrous bone, ancient genetic secrets remained, waiting for science to catch up. When that day arrived, the past would speak louder than ever before. For decades, researchers were haunted by a tantalizing thought. What if the answers to the oldest mysteries of human evolution were still locked inside the bones, preserved at a microscopic level? But the obstacles were enormous. Ancient DNA is fragile, easily degraded by heat, humidity, and time. The African climate, where many of the oldest human remains are found, posed some of the worst conditions imaginable for DNA preservation. For years, scientists tried and failed to retrieve viable genetic material from these ancient fossils. Then, something changed. Advances in paleogenetics, specifically techniques that target the dense petrous portion of the skull and amplify even the most fragmented DNA sequences, opened a new frontier. Researchers at leading institutions like the Max Planck Institute, Harvard, and Addis Ababa University began revisiting some of the oldest human remains ever discovered. In 2021, a team successfully extracted and sequenced DNA from a set of ancient remains found in Eastern Africa that were more than 230,000 years old. It was a monumental breakthrough. For the first time, they weren't just looking at bones, they were looking into the biological past of our species. The results were nothing short of revolutionary. The genome they recovered revealed that the individuals belonged to a population that is genetically closer to all living humans than any other known fossil group. In other words, this wasn't a cousin species or an extinct line. These were direct ancestors of modern humans. Even more fascinating, the DNA showed traces of gene flow between these early Homo sapiens and other archaic hominins who lived in Africa, groups we still know very little about. It hinted at a complex web of interbreeding and interaction between different human populations long before the Great Migrations out of Africa began. One of the most stunning revelations came when this ancient African DNA was compared to genomes from fossils found in other parts of the world. The patterns of shared ancestry helped confirm that all modern humans today, regardless of race or nationality, can trace their lineage back to a single ancestral population in Africa. That population, it turns out, included the very individuals whose remains had sparked debate for decades. The mystery wasn't just solved, it was rewritten with genetic certainty. The moment ancient DNA placed those earliest remains directly in our family tree, the scientific narrative of human origins began to shift. For over a century, the out-of-Africa model had dominated the story. Homo sapiens evolved in East Africa, then spread across the globe, replacing all earlier hominins without much mixing. But the genetic evidence painted a far more complex, intertwined picture. It showed that early Homo sapiens weren't a uniform group radiating outward from a single point, but rather a patchwork of interconnected populations spread across Africa. These groups migrated, mingled, and exchanged genes for tens of thousands of years before some lineages eventually moved beyond the continent. It wasn't a singular origin, it was a braided stream of evolution. The data revealed that human evolution was not linear or clean but messy, dynamic, and shaped by repeated contact between distinct groups. Some of the DNA in modern humans even comes from now extinct archaic populations in Africa that we've yet to identify by name or fossil. These ghost lineages live on in our blood but not in our bones. The discovery also sparked a re-examination of ancient remains outside of Africa. Researchers began comparing genomes from early Homo sapiens found in places like Israel, Siberia, and Southeast Asia. They found similar traces of complex ancestry, suggesting that as humans migrated out of Africa, they didn't just replace older populations, they sometimes merged with them. This helped explain the presence of Neanderthal and Denisovan DNA in many modern humans. Ancient DNA allowed scientists to move beyond theories based solely on bone shape or tool types. It provided a direct genetic map of human ancestry, migration, and mixing. In doing so, it bridged science with stories long told by indigenous cultures, that humanity's roots are diverse, interconnected, and far older than once believed. The origin of the oldest human remains was no longer an academic puzzle, it became a living link to all of us. I'm on a road to get 1,000 subscribers as a small channel. If you want to help me, please subscribe. For decades, the oldest human remains were silent witnesses to a past we barely understood, but with the power of ancient DNA, they've found their voice. They tell a story not of isolated ancestors or lost branches, but of unity, movement, and deep connection across time. They reveal that humanity's origin is not a single birthplace but a continent-wide legacy shaped by complexity and resilience. And they remind us that beneath our differences lies a shared beginning, etched into our very cells.